That was a most generous introduction. So today I'm going to talk about, I've given myself the challenge of thinking about resilience, and in particular what is known as ecological resilience in coupled human-built natural environments, but actually with the emphasis on the built environment, not least because that's what infrastructure is associated with. And there you see that I'm doing this with a postdoc at the University of Georgia, and very much so with Michael Thompson, with whom I've had the pleasure of rubbing shoulders for 15 or more years and learnt an enormous amount from Mike, and also been thoroughly entertained by him on many occasions. So part of the charge for this conference was, can we imagine resilient infrastructure systems? So that's what I've given myself the job of doing. And let's start with something which dresses us all down to size. I was delighted, I think I was delighted to wake up early one morning in the States to listen to somebody, National Public Radio, reporting on the Cancun Climate Conference in December 2010. And John Perry Barlow of Algae Systems had gone there because he wanted to start a business up in generating renewable biofuels. And he would do this by taking the nitrogen and the phosphorus from wastewater, combining it with the carbon in the atmosphere, and producing algae, which are a nuisance species of organisms, or generally thought to be so when in the natural environment, or can be, and then express a biofuel from the algae biomass. And so I thought the title, Climate Change, Big Issue, Drives the Market for an Incredibly Tiny, Intimate and Local Issue, Urine Separating Toilets, was something that would scramble the brain, scramble the traditional thinking about infrastructure, and probably also reveal my background. It doesn't make much difference to people who are not engineers, but I'm not a civil engineer, I'm a chemical engineer, and then a control engineer. And so a slightly different background to have if you're thinking about environmental engineering. This is, called it a narrative. I'm seeking an ecologically resilient future-built environment, or next-generation infrastructure, brought about by an ecologically resilient policy instrument and managed in an ecologically resilient style. Enterprise risk management, together with resilience in particular. Now, I have to say, it's probably a great benefit to you that this talk was cut down from 45 minutes to 30 minutes, because the last bit gets really flaky, and I probably shall be protected from some embarrassment by having it stopped short. And by the way, who's going to wave at me to tell me to cease talking when we run out of my 30 minutes? Joanne? And I don't want to review resilience through the ages. I could do. There's a notice out there that celebrates Buzz Holling's work here at EASA. I came just after Buzz was here the first time, and I left when he came the second time as director. And what I'm going to do is or what I've been trying to do, is to build an understanding of ecological resilience in particular through various systems, running from engineering through ecology, business, finance, economics, architecture, mathematics, socio-technological transformations. Interesting one which I haven't found out how to exploit yet, species biology and evolutionary opportunities. Some very interesting things that were said by Holling on that subject and are not often exploited in thinking about things like infrastructure. And anthropology. And I've got 7 case studies which I probably will manage to talk about. So I want to balance the conceptual development, which I have a propensity for thinking about, with some real-world case studies of things actually happening in practice that demonstrate certain facets of ecological resilience in the built environment. So seeking to put this succinctly, hopefully, mutually reinforcing ecological resilience, not only in the natural environment and the human environment, but also the built environment. Historically, the built environment from this perspective has been shortchanged, probably for very good reasons. It's very, very difficult to think about ecological resilience in concrete systems. But we have Holling, who I think gave some most seminal, impressive insights into ecological resilience beginning in the 1970s. And in the early 2000s, Michael Thompson mapped all of Holling's ideas out of ecology into social systems. And that is often overlooked, even by the Resilience Alliance people in Stockholm, as far as I can establish, but it's extremely important. So in the natural environment on the one hand and the human environment on the other hand, we actually have quite a decent understanding of what would constitute ecologically resilient systems behavior. But in the middle, in the built environment, I don't think we have a good understanding of that. And I'm disciplining myself to try and say something of something sensible about that subject. I will start with Holling, 1973, just to say that he distinguished between engineering resilience and ecological resilience. And ecological resilience, we may be living in a not optimal or not particularly comfortable world, but at least a functioning infrastructure system. And I've attached this also to Taleb's ideas about antifragility. I have to admit I'm not a great one for following fashion too quickly. I mean, as we listened to the gentleman yesterday talking about the World Business Council for Sustainable Development, some of us would have been persuaded in 2011 that should change from sustainability to resilience. And here we have another word, not an S word or an R word, but an A word for anti-fragile. And I will describe what Taleb means by that. This is Taleb of the black swan, and I think that was why somebody asked one of our speakers what was the colour of the swan on the railway track at Oxford yesterday, but it was called the red swan in the end, because presumably got mangled by the train going over it. So Taleb, who is not a man without strong opinions, has observed on London's Heathrow Airport, as doubtless all of us can, except those of us who only need to go to London. If you have to change at Heathrow, I dare say it's a lot more difficult than I find it. And he said, we want both engineering resilience, which I won't really talk about, and ecological resilience. We want smooth functioning under normal times, optimal, and rough functioning when the system is under stress. We don't want the airport to close down because there's 1 centimetre of snow on the runway. We want to have, let's say, 30% operation of the airport under that stressful situation. And how do we develop infrastructure so that it can actually achieve that kind of ecological resilience? I actually find that there's not a lot of water between the notion of anti-fragility and ecological resilience, not that Taleb cites Holling's work. So case study 1. So I've got 7 case studies, more or less. This is for the city of Kent in Washington State, USA. And it will be a discussion of really, I think, more community resilience than infrastructure ecological resilience, and resilience in the face of floods. And I suppose the take-home message is bring on the floods. Not an attractive notion, as I'll talk about perhaps in a minute. So the work that's being done here is by somebody who is now in Hong Kong, and she's been railing against the fact that we have over 100 years or more built a flood-resistant infrastructure for cities. In other words, we are basically going to reject all disturbances hitting the city. Water shall never come into the city. It is absolutely not allowed. And she is seeking to turn that around to the idea of a flood-resilient city. And she argues that ecological resilience resides in the human environment, not the built environment. And then she goes on to say that every small urban flood is a learning opportunity, so that we shall then be all the better forearmed to deal with the big one when it comes. Well, I have to say I'm not terribly keen on my house in Barnes, Southwest 13, London, being flooded, so that the rest of London can learn how to deal with bigger floods when they come along in the future. But nevertheless, the idea is that the city should be a learning organisation, I suppose, and that there is uncertainty about the environment, and so we're continually needing to learn from this buffeting and muted response of the systems that we're dealing with. So bring on the floods. This is the city of Kent in Washington, looking at flood resilience. These are stage props to prove that some of this work is actually directed at specific case studies on the ground. And Liao published a paper this year on how you could rework the flood-resistant infrastructure of the city of Kent to be something that's flood resilient. And so she looked at large-scale floodplain restoration and the creation of off-channel habitats. It's actually quite important in Washington state for the salmon fry, if that's the correct, or the juvenile salmon, to have low-velocity refugia in the floodplain of rivers so that they can hide from the flood before they rejoin the mainstream of the river and migrate back to the ocean. And so she's looking on the right-hand diagram at how many sorts of refugia and other places for the wildlife, fish habitat to be restored and reconstructed. And there is a broader issue here of the time dimension of ecological resilience, which is actually where Holling started, rather than the spatial dimension of resilience, which I'll come on to in a minute. And the way that I see this, as indeed I think Holling did, is in terms of frequency spectrum, which actually, if you think about rivers, we see the fish assemblages and the ecologies of the rivers that we had before cities arrived. We see them there because they co-evolved with all the pulsating, pounding variety of disturbances to which they were subject. And when we build cities, we basically appropriate everything from the environment to serve just the narrow bandwidth, nothing like the full spectrum, the narrow bandwidth of the now commonly used phrase, the 24/7. So the city basically works with a heavy emphasis on the 24-hour cycle and the 7-day cycle. And by the way, I ask you to think of an ecosystem that evolved in sympathy with a weekly cycle of disturbance. I don't think there is one. There may be one now that things have become habituated to cities, but historically we didn't have that frequency so dominant in the orchestra or the symphony of environmental disturbances to which ecological systems are subject as they co-evolved with those disturbances over the eons. Developing further the conceptual basis of resilience. Again, the title of Taleb's book, Antifragile, Things That Gain from Disorder. I probably need to read these out, which will unfortunately take quite a bit of time. Stressful, moderately harmful disturbances and disruptions induce an overcompensatory response, hence to strengthen the system against future slings and arrows of outrageous fortune, i.e. black swans. So this should help us to be all the better forearmed against the big one when it comes, and come it will. So the message again is, hey, bring on the floods as learning opportunities, and let us not forget the temporal dimension of resilience, which has to do, I think, most succinctly with the frequency spectrum, and we're all familiar with bandwidth and the fact that cities operate with a very narrow bandwidth, but the environment didn't operate that way before. Case study 2, Barkley Tower, New York City. I read about this before Hurricane Superstorm Sandy hit New York City, and the whole point was a battery technology company was working to develop batteries that would enable the lights to stay on in this new high-rise building, the Barkley Tower, for a longer period of time should grid power be lost entirely. So here we're looking at, and this is not a US election, but I think the statement bears saying, it's the network, stupid. And I certainly felt that yesterday, where there was a lot of discussion of the network from a spatial organizational point of view. And we're looking here at ecological resilience through modularities and linkages and clusters of ever more intelligent buildings. And I should say that regional economists, and there was mention of the Cambridge economics projections for the ITRC project yesterday, Ron Martin has written a very, very interesting paper on resilience in economic systems, and talks very much about economic systems surviving crashes through various modularities and linkages in the networks that constitute regional and city economic systems. So the only ingredient that I'm going to add to all the discussion about spatial networks and their connectivity yesterday is the idea of buildings becoming more intelligent agents almost by the minute. Again, a lot of time here. Ecological resilience is generated by diverse but overlapping this is an extremely important insight for me. I don't quite know how to use it yet, but it comes from Holling and his colleagues Peterson and others, 1998, and they were looking at trying to understand resilience in ecosystems through looking across the sort of hierarchical arrangements in which ecosystems can be found. Ecological resilience is generated by diverse but overlapping function within a scale and by apparently redundant species that operate at different scales, thereby reinforcing function across scales. The combination of a diversity of ecological function at specific scales and the replication of function across a diversity of scales produces resilient ecological function. And I would just say, take that understanding, that insight from ecology, and substitute ecological species by buildings or unit processes in a wastewater treatment system, or buildings that are becoming more human and intelligent by the minute, smart buildings. Substitute buildings in that insight and see what that reveals for thinking about ecologically resilient clusters and networks of buildings in a city. So here's the Barkley Tower in New York City, becoming ever more agent-like by the minute, by the day. I tried to find out whether the lights had stayed on in the Barkley Tower after Hurricane Superstorm Sandy, but Googling as I could and would, I couldn't find any evidence of whether the lights had stayed on a little bit longer than everywhere else in New York City after that event. And here I introduce something from a mathematician come architect, Salingaros, who is something of a gadfly with regard to the architectural profession. And he argues that livable cities have networks within them that have a fractal self-similarity about them. So from walking networks to cycling networks to perhaps automobile networks to subway networks should have some sort of network property of fractal self-similarity about them, and that constitutes livability in a city. So, and there he's constructing a hierarchy, and of course he argues that the car distorted the fractal self-similarity within the system, and that we need to go back to walking networks, cycling networks, and subway networks that replicate that self-similarity as we go up through spatial scale and hierarchy in the system. Remind ourselves of where we are, because I may have strayed from the point a little bit. We're looking at, could we imagine mutually reinforcing ecological resilience in the natural world, restoring it there, in the human world, and in the built environment? And in particular, in the built environment, swapping out grey infrastructure for green infrastructure, which I think is possibly the next, case study. So this, and I'm sure the Dutch people in the room will laugh at my pronunciation of this word, although I'll have a go, Surendonk sewage treatment plant in the Netherlands. And here you see an example of resilience being brought about in that grey-green infrastructure through habitat reconstruction, or actually habitat construction. So now we're trying to create ecological resilience in the built environment through importing ecology, hence ecological resilience into that built environment. And Surendonk goes further than most wastewater treatment plants in this respect, in the sense that you have the grey infrastructure of the wastewater treatment plant here, and then a sequence of greener parts of the infrastructure, from a flea pond to a reed wetland to a biotope here. And there's actually a fish ladder here. And so the wastewater treatment plant is designed to be flooded when there is excess water in the system, and also allow fish to take refuge in the wastewater treatment plant, and then come back into the river system as the flood subsides. And there's even a fish ladder. And the whole point is to design the wastewater treatment plant so that it can seed the river with its natural flora and fauna as part of. Actually, the title for this particular case study was "The Surendonk Wastewater Treatment Plant Blurs the Distinction Between What the City Is and What the Environment Is." Fourth case study, Atlanta, Georgia, USA, one that I've been working on myself. And here we're looking at, could we use the entire wastewater infrastructure of Atlanta to generate nutrient supplements, just like we take nutrient supplements, from resource recovery in the wastewater infrastructure, and to dispense those nutrient supplements to enhance the resilience of the ecosystem services that surround the city of Atlanta. quite a challenge to imagine this. And this, again, introduces the time domain rather than the spatial domain of spectrum as a facet or a dimension along which ecological resilience can be interpreted. Here's Atlanta, the blue bit, situated, well, it occupies a large portion of the Upper Chattahoochee watershed, and the yellow dot is where the R.M. Clayton wastewater treatment plant is. And so we imagined on the computer that over a span of 30 to 40, 50, 60, that's the great thing about sustainability, you have to imagine it 2 or 3 generations into the future, that that wastewater treatment plant would be, and indeed the household plumbing in the city of Atlanta and the sewer network would be re-engineered such that, get thee back, such that here we could recover phosphorus and nitrogen, i.e. fertilizer, and dispense it to the river system to reconstruct the spectrum of not flow disturbances or sediment disturbances in the river system with which we're familiar, but the nutrient disturbance spectrum in the river, with which we presume the fish that we see in the Chattahoochee River co-evolved with over the eons to deliver what we used to know as the ecosystem services around the city of Atlanta. And there, what you're seeing is a base level of phosphorus in the Chattahoochee River with these peak nutrient supplements being dispensed to the river system. And I don't want to get tied up too much in talking about spectrum in the slide after this, but that picture, the previous picture, is reminiscent of this image here, which is what ecologists are trying to work with to manipulate the grey infrastructure of rivers like the Savannah River, the dividing line between the states of Georgia and South Carolina, to manipulate that grey infrastructure to reconstruct parts of the spectrum that were completely removed when the river was successively dammed for storage and hydropower generation and flood attenuation and so forth. Can we manipulate those sluice gates, those dams, to reconstruct this, a richer spectrum of disturbances to which that river system is subject in terms of its flows, not its nutrients, such that we can have more resilient fish assemblages as they existed prior to European settlement in the US in the Savannah River and other southeastern United States rivers previously. That's called environmental flows. And it's all to do with spectrum manipulation. And this diagram doesn't actually relate to that. But what we were thinking about was a pre-city spectrum of environmental disturbances spanning from seconds to centuries to millennia to eons, and how man has manipulated that frequency spectrum, and in particular emphasized variations with a weekly periodicity and a daily periodicity. So I'm concerned about trying to, in the time domain, although this is the frequency domain, I never understood electrical engineering until I came across having to work with this problem. I just wasn't good on sinusoids, but now I do understand why control engineers think about the frequency spectrum. Let's move on quickly. It's quite a complicated thing that. This is not just a figment of my imagination, and I love this story because it re-emphasizes how fact is stranger than conceptual research. Yes? Okay, fine. So here we have a case study of Durham, Oregon, and Vancouver Island, British Columbia. And the infrastructure of the city of Durham is being used to recover phosphorus as a fertilizer, bag it, and then ship it to Vancouver Island, where the bags of recovered phosphorus from the wastewater treatment plant are dumped in Vancouver Island streams to restore declining salmon populations. So this is turning on its head 50 to 60 years of environmental policy relating to water quality management. So here's the technology. It's this process for recovering a nice, easily handleable fertilizer, which is then bagged and shipped 450 kilometers, I beg your pardon. Not sure of the economics of this. And there you can see the recovered fertilizer in the bags, which is being dumped, not in the pejorative sense of dumping sewage in the stream, but to reconstruct declining salmon populations. And it was a palpable case study manifestation of what I'd been working with on a computer. So there we have, as it were, the idea of cities and their infrastructures as forces for good in the environment. Case studies I've talked about so far give us a glimpse into ecological resilience in the time domain, the spatial domain, and I suppose the biogeochemical processing dimension of green ecological infrastructure. And again, in that Vancouver Island example, though I didn't explain, didn't have time to spectrum time domain again. So bringing it about in very short order. Understood and appreciated, Joanne. And also this is where it gets a bit flaky. Okay, so how are we going to make all this happen? And what is the great bounty that's out there to be recovered if we could change the way we think about wastewater infrastructure? Backdrop to this is a case study of London, UK, its urban metabolism, and thinking about smarter urban metabolism for London and nutrient recovery in particular. And I'm going to imagine or ask you to think of 3 scales of system. I suppose at the small scale, the individual firm and its enterprise risk management and ecological resilience in that enterprise risk management, the large scale, the urban regional economy and resilience in that, and then as a policy instrument, an innovation ecosystem and its resilience. Now, some of you may have heard of the innovation ecosystem, and my view is if people are going to talk about this, and they do liberally in the oddest of places talk about ecosystems, like why do teenagers live such stressful lives now that there's all the social media in which they participate in? And I heard somebody talking about the cultural ecosystem in association with that. If we're going to talk about an innovation ecosystem, then why not see how ecologically resilient as a policy instrument it might be made? Move on very quickly. The bounty that's at stake here is literally potentially globally billions of dollars in recovering nutrients, fertilizer from urban wastewater infrastructure, and even more so from cattle and swine manure and poultry litter. So you've got about 15 or 16 companies there, and we've assessed their global markets for recovery of nutrients from urban wastewater infrastructure. That's the prize that's out there. If only we could change our mindset, and what policy instrument would bring about that transformative change. Now, I don't know how many of you are familiar with this adaptive cycle from Holling's work. I can be corrected, maybe it was 1986 or maybe it was as late as 2002. So we don't develop just from A to B. We don't develop from a pioneer community to a climax community. We can, of course, experience creative destruction where the whole thing starts all over again. And that's the adaptive cycle. And particularly for wastewater treatment, where we've been, as somebody put it, resting on our laurels for 100 years, what sort of disruptive perturbation could we bring to the system? Is that even desirable? And I like to think, because I'm working in the energy sector, the water sector, the food sector, the waste handling sector, I think it would be extremely good for the water sector if it had some invasive cross-sectorial entrepreneurial species invading it and rearranging all the components of the water sector and bringing about a bit more innovation than there is currently. So this is the culmination of Holling's work called Panicky in a book with Gunderson. And so here we have the threefold arrangement of systems of large regional economy, small individual firm here, and an innovation ecosystem in the middle. And I would say about what I've read of innovation ecosystems, it really is the network stupid. Why? Because one of the most impressive case studies that I've come across, rushing here, is the idea of an innovation ecosystem being used in regenerating the regional economy of Northeast Ohio. This is my 7th case study. And it was interesting, Peter Backer said yesterday, we need courage, we need leadership. This comes from a book by Katz and Bradley called The Metropolitan Revolution, and they deliberately titled this chapter on the regeneration of Northeast Ohio's economy, the post-hero economy, because there was no hero on a white horse with courage and leadership who came in and turned things around. It was actually a non-governmental philanthropic fund that was actually instrumental for holding that innovation ecosystem together and transforming the regional economy of Ohio. And that the innovation ecosystem had an extremely flat hierarchy, very difficult to determine who was the leader and who were the participants. Sustaining affairs, Joanne, this is one last thing, but I would hate to finish this talk without at least recognizing some of Mike Thompson's work. So this alludes to work that Mike was doing with Dave Ingram, who works for Willis Re, as in the insurance business and based in New York City. And Dave gave a talk, I think, to the New York Stock Exchange in March last year, and he talked about how he understood resilience post-Hurricane Superstorm Sandy. And he then began to talk about how conventional enterprise risk management does not do a good job of investing in long-term resilience of firms and businesses. Again, really difficult to sort of work one's thoughts through these diagrams. But in Mike's theory of plural rationalities, we have 4 rationalities: the risk managing rationality, the risk avoiding, the risk taking, and the risk absorbing rationales. And conventional enterprise risk management is focused on an outlook towards risk, which is fundamentally risk managing. And one of the things that happens in certain economic times is that if you're in a moderate economic environment, which is benign, companies do everything they can, presumably, to increase efficiency and eliminate redundancy, thereby making themselves progressively more fragile for when the economic times change and the risk environment changes and circulates and cycles through a number of seasons of risk exposures or types of risk. And so one such cycle which we know of well is we have a benign, moderate environment, which we had from maybe the early 1970s through to about 2006, 2007. There are certain individuals who start to make lots of money, who take over all the decision-making, come to dominate. We get a boom, then there's a bust, and then it can be argued that the stock market and the economy enters an uncertain period, which would demand a quite different kind of risk approach or risk handling approach than that which is associated with the moderate and for which all the work has been done on enterprise risk management. So, Joanna, I'm now finishing. My conclusions, and I'm sorry I was a bit hurried with the most complicated parts of what I wanted to say, but I'm fascinated by trying to translate those ideas of Holling and Gunderson and Panicky across into infrastructure systems. Can we not imagine but realize ecologically resilient next generation infrastructure? Mission impossible. Mission impossible. And besides, what I said was far too conceptually elegant, neat, and tidy. The real world isn't like that. But I like missions impossible. Am I a masochist? I'm not sure. The reason I like bearing down on missions impossible, and frankly, I haven't borne down enough on this ecological resilience issue, is that you may never solve the big question that you started off with, but in leaning on it again and again and relaxing and standing back and leaning on it again, you may come up with really good questions that you wouldn't have thought of asking, but which can be answered, sort of answered, if you hadn't been thinking about the mission impossible in the first place. So that's why I like missions impossible, but you have to have a lot of, well, hey, look, all this is going to take us a lot of time. And so I'm now looking at work by Heels on socio-technological transformations, transformative processes, which he calls sustainability transitions. Actually, his work is being connected by others at Sprue into notions of ecological resilience, panicky innovation ecosystems, and I'm trying to see what new questions can be posed there and reasonably answered within my remaining lifetime. Thank you very much.